Hello students, welcome to physics CT classes. I hope you are doing good. Right. So in today's class, we are going to start a new chapter called Dual Nature of Matter and Radiation. Okay. So I hope in the last class, whatever we have had the discussion, we are clear with that topic. Okay. So before going to with the multiple choice question, let us have a brief discussion on the formulas. So you can see here in this particular topic, we are going to have the concentration on how the particles will be moving. So basically you are going to study about here the particle nature and the wave nature, right? So you would have studied about in this chapter the photons, right? What is photon? Photon is a packet of energy emitted from a source of radiation. Correct. So photons are a carrier particle of electromagnetic interaction. Photons travels in a straight line with the speed of light. You have studied about the characteristics of the photon. Okay. So here the very important thing you have to remember is the energy. So energy of photon is given as, you can see here, the energy of photon is given as E is equal to h nu. E is equal to h mu, that is equal to hc by lambda. Okay, then momentum of photon, so E is equal to, that is p, that is small letter p, momentum. So p is equal to E by c, or h mu by c. The moving mass m of photon, so mass they have given us, then all the photons of light of a particular frequency or wavelength have the same energy and the momentum, whatever the intensity of the radiation might be. Okay, the number of photons emitted. So this formula also is very, very important. So stopping potential, you can also call it as the kinetic energy, that both are going to be equal. Okay, if the light of frequency is incident on the photosensitive, the work one, then the maximum kinetic energy is given as, this is also called as Einstein equation, right? So where you can say 5 naught is nothing but work function. Okay, so here on condition, if the frequency is greater than the threshold frequency, or this will be the equation. So this formulas, everything is very, very important. Next, De-Broglie wavelength is given as lambda is equal to h divided by p, or h by mv. Next, if the rest mass of the particle is m naught, its de Broglie wavelength is given by lambda is equal to h into, that is h into square root of 1 minus v square by c square whole divided by m naught v. So kinetic energy, that is de Broglie wavelength, in terms of kinetic energy is given as lambda is equal to h divided by square root of 2 mk. If the particle of the charge q is accelerated through a potential difference v, then this will be the auxiliary lambda in terms of v. Then finally, if you substitute all the values, you'll be getting 1.227 divided by root v in nanometer. Then for electron, this will be the formula. Directly you can substitute that formula. So for a gas molecule of mass m at temperature T, so at that particular time, you can use the De-Broglie wavelength. So where K is nothing but Boltzmann's Boltzmann constant. Okay, please make a note of this. You can copy down that. I hope you have written this right. Okay. So see the first problem. What is the kinetic energy gained by an electron due to an acceleration through a potential difference of 1 volt? So you have that. So gain in kinetic energy is nothing but Q into V. So Q all there, you know that 1.6 into 10 to the power minus 19 into 1 volt. But you please remember that in modern physics, you have to, so in the modern physics, whatever we are going to study, you have to write it in electron volt only. Okay, so you have to write it in electron volt only. So I'm going to divide that with 1.6 into 10 to the power minus 19. So this and this get cancelled. So it is 1 electron volt. So option 1. Next, find the number of photons emitted per second by a 25-watt source of monochromatic light of wavelength 6000 Armstrong. So you have the formula that number of electrons alva. So first E is equal to hc by lambda. Second you have the formula n is equal to p divided by E. Okay, that is nothing but power divided by E. So h is nothing but 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8 whole divided by the lambda is 6000 Armstrong ಅಂದ್ರೆ 6000 into 10 to the power minus 10. Try ಮಾಡಿ. So 6.62 into 3 ಅಂದ್ರೆ 19.86 divided by 6 into 10 to the power 3. So ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ 10 to the power 34 plus 8. If it shifted to the numerator, again it is plus 10 only. So again, so it is 3.31 into 10 to the power minus 34 plus 8 is 20 minus 26. It is minus 16 Again 10 to the power plus 3 ಮೇಲೆ ಹೋದ್ರೆ minus 3. So it is 10 to the power minus 19 only. Okay, that is your E. We'll substitute ಮಾಡ್ತೀನಿ. 25 divided by 3.31 into 10 to the power minus 19. Now 1, 2. So ಇದೆಷ್ಟಾಯ್ತು 25 divided by 331 into 10 to the power minus 2 into 10 to the power minus 19. So 10 to the power minus 21 ಅಲ್ವಾ? So ಈಗ 25 divided by, you will get 0.0755. So 1, 2, 2 andre. So finally you'll get the answer as 7.55 into 10 to the power minus 19. That is your n value. So option 1 only. ಬರ್ಕೊಳ್ಳಿ. ಸೊ ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ನೋಡಿ. A steel ball of mass m, moving with a kinetic energy, the De-Broglie wavelength associated with the ball is. So it is directly, you can write, we have already studied, h divided by root of 2m k. Now they are asking about the velocity. The maximum velocity of an electron emitted by light of wavelength lambda incident on the surface of a metal of work function is. So you have the formula that so work function andre phi naught, right? So you have the formula E andre ke is equal to h c by lambda, hc by lambda minus 5. So agideno hc minus lambda 5 divided by lambda ಇದು half m v square. So v square is equal to 2 ಇಲ್ಲಿ ಹೋಗುತ್ತೆ. So 2 hc by lambda 5 whole divided by m into lambda. So root ತೆಗಿತೀನಿ. V is equal to 2 hc minus lambda 5 divided by m lambda. So instead of writing square root, I'm writing 1 by 2. So option 2. Title, right. What is the de-Broglie wavelength associated with an electron accelerated through a potential difference of 100 volt? So you have the direct formula. Lambda is equal to 1.227 divided by root V. So V they given as 100. So 1.227 divided by root of 100. So it is 1.227 divided by 10. So it is nothing but 0.1227. So Adilla, you can say that you can round off. So 7 is more than 5. So plus 1 at whatever it is 0.123 nanometer. So option 1. Okay. So if alpha particle of mass m are accelerated by the potential difference of v volt, then their wavelength will be h is equal to 2 times the mass into ev. ಫಾರ್ಮುಲಾ ಆಲ್ರೆಡಿ ಮಾಡಿ ಓದಿದ್ದೀವಿ ಅಲ್ಲಿ ಸಿನಾಪ್ಸಿಸ್ ಅಲ್ಲಿ. ಓಕೆ, next, an electron volt is an unit of energy. Unit of energy. If the velocity of all the particles is same, then which of the following particles will have associated will associate matter waves of minimum wavelength? It is nothing but alpha particles. In Dyson experiment, nickel crystal diffracts the electron beam. Diffracts the electron beam. If the wavelengths of proton and photon are same, then which of the following quantities will be same? Momentum. In Davison-Germer experiment, an electron beam of desired energy can be obtained by varying accelerating voltage. In Davison-Germer experiment, an electron beam is incident on crystal. The reflected beam is incident on a crystal. The reflected beam consists of electrons. All the theory based. Okay. Then the de-Broglie wavelength of an electron moving in the nth Bohr orbit and Bohr orbit of radius r is given by, okay, so Bohr andre you have the thing is it is 2 pi r is equal to n into lambda. So ಅವ್ರು ಕೇಳ್ತಾರೇನು, lambda is equal to 2 pi r divided by n. Okay, so option 1. The potential difference applied to an X-ray tube is increased as a result in the emitted radiation. So you have intensity remains unchanged, the minimum wavelength decreases. So both also possible. Both also is correct. Next, in a photoelectric effect, electrons are emitted. So with a maximum velocity proportional to the frequency of the incident radiation at a rate that is independent of the intensity of the incident radiation, only if the frequency of the incident radiation is above the threshold value, only if the temperature of the emitter is higher. So to understand, you can start telling about that. So again, you can say the kinetic energy is equal to h mu minus 5 ಅಂತ ತಗೊಂತೀವಿ, ಕರೆಕ್ಟಾ? ಸೊ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡು ಹೋದಾಗ ಈಗ ಒಂದೊಂದು ಕೇಸಸ್ ಅಲ್ಲಿ ನೋಡಿದಾಗ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೇಲೆ ಇಟ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್, ಕರೆಕ್ಟಾ? So finally you can say only if the frequency of the incident radiation is above a threshold, option C. Okay, a potential difference of 20 kilovolt is applied across an X-ray tube. Find the minimum wavelength of X-rays generated. The X-rays produced under an accelerating potential will have varying wavelength with the minimum due to the entire energy of the accelerated electron being lost in single collision. Again, you can say hc by lambda is equal to 20 into 10 to the power 3 E, andre this is nothing but hc is equal to electron volt. ಓಕೆ, ಅದಕ್ಕೆ ಅದನ್ನ ಏನು ಬರೀತಾ ಇದ್ದೀವಿ, 20 into h to the power c ಅಂದರೆ e ಅಂದರೆ ಎಷ್ಟು v into 1.6 into 10 to the power minus 19 is equal to hc by lambda. So lambda ಬೇಕು ನನಗೆ, so lambda is equal to h is 6.62 into 10 to the power minus 34 into 10 into 3 into 10 to the power 8 whole divided by 20 into 10 to the power 3 into 1.6 into 10 to the power minus 19. ಸಾಲ್ವ್ ಮಾಡಿ, ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ ಆನ್ಸರ್ ನೀವೇ ಟ್ರೈ ಮಾಡಿ. ಟ್ರೈ ಮಾಡಿ. ಸೊ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಪವರ್ ಬಂದು 10⁻⁻10 ಬರುತ್ತೆ. ಇದು 0.62 ಬರುತ್ತೆ. You can write it as 0.62 Armstrong. ಅಬ್ಸರ್ವ್ ನೋಟ್ ಬರ್ಕೊಳ್ಳೋಣ. I hope you're done. Next one. An electron of mass m, when accelerated through potential V, has De-Broglie wavelength lambda. The De-Broglie wavelength associated with a proton of mass m accelerated through the same potential difference will be. So you can say from the formula, okay, from the formula, what is that? Lambda is equal to h divided by root of 2mk. You can say lambda is inversely proportional to root of m, right? Right. So ಇಲ್ಲಿ lambda 2 divided by lambda 1 is equal to root of small m divided by capital letter M. So lambda, okay, lambda 2 is proportional to 1 by root of capital letter M. So you can write that as, so instead of taking lambda 1, I'm going to write it as lambda only. So again I thought it is capital letter M divided by small letter m. So lambda 2 is equal to lambda into root of m divided by m. ಕರೆಕ್ಟ್ ಚೆಕ್ ಮಾಡಿ. ಓಕೆ, ಒಂದ್ಸಲ ನೀಟಾಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿಲಿ. ಸೊ ಥಿಂಕ್ ವಾಟ್ ಎವರ್ ವಿ ಹ್ಯಾವ್ ರಿಟನ್. ಓಕೆ, ಈಗ ನೋಡಿ, ಆಸ್ ಫ್ರಮ್ ದ ಫಾರ್ಮುಲಾ ಯಾವುದು, ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಹೆಚ್ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ ಆಫ್ 2mk. So from this you can say lambda is inversely proportional to root m. So now they told lambda 2 by lambda 1 is equal to 1 by root of capital letter M. ಅದವ್ರು ಕೊಟ್ಟಿರೋದು ಸೆಕೆಂಡ್ ಒನ್ಗೆ ಕ್ಯಾಪಿಟಲ್ M, 1 by root of small m. So lambda 2 is equal to, they given lambda 1 is equal to lambda. So I'll shift that to other side. root of m, small m will go to the numerator. This comes to the denominator. So root of small m divided by capital letter M. So option 2. ಅರ್ಥ ಆಯ್ತಲ್ಲ? A particle of mass m is projected from ground with the velocity u, making an angle theta with the vertical. So at the maximum height, velocity at the maximum point, you can write it as v is equal to u sin theta, right? Why? Because the component moving upward is sin theta. So v is equal to sin theta. So lambda is equal to h divided by m into v. You can write this as h divided by m u sin theta. So option 2 is the right answer. Next, a material particle with a rest mass m naught is moving with a velocity of light c. Then the wavelength of the De-Broglie wave associated with it is. Since we can say rest mass is 0, right? Then the wavelength also becomes 0. So option 2. Option 2. It is also 0 only. The De-Broglie wavelength of a particle is the same as the wavelength of photon. Then the photon energy is. They have told that you can take in terms of C and particle, right? You are going to take the comparison between the E and Ke. So you can say, according to the concept, so that is the photon energy is greater than the kinetic energy. ಏನಕ್ಕೆ ಅಂದ್ರೆ it comes under the root kinetic energy. ಈ ಫಾರ್ಮುಲಾ ನೋಡಿದ್ದೀರಾ ಅನ್ಸುತ್ತಲ್ವಾ? What is that? Lambda is equal to h divided by square root of 2m k ಅಂದ್ರೇನು kinetic energy. In general ತಗೊಂಡಾಗ okay, they have told hc divided by e is equal to okay hc ಅದೇ ತಗೊಂಡ್ರೆ divided by root of k. So e is greater than kinetic energy. Rooted in the k to the power 1 by 2. The value will be smaller compared to e. So that is the intention. That is the reason we can say photon energy is greater than the kinetic energy of the particle. The De-Broglie wavelength of electron in the first Bohr orbit of hydrogen atom is equal to, already ಅದನ್ನ ಬರ್ದಿದ್ದೀವಿ, 2 pi r, right? It is equal to the circumference. It is equal to the circumference of the first orbit. You have the formula that 2 pi r is equal to n into lambda. Okay, where both orbit andre n is equal to 1 ಆಗುತ್ತೆ. So lambda is equal to 2 pi r. In 2 pi r, it is nothing but circumference. Next, an alpha particle and a singly ionized atom are accelerated through the same potential difference. What is the ratio of de-Broglie waves in two cases? Okay, you can say that lambda is inversely proportional. So you can write that as lambda is inversely proportional to 1 by root m into q. So just the terms ನಾನು ತಗೊಂಡಿದ್ದೀನಿ ಅಷ್ಟೇ. ಈಗ ಅವ್ರು ಕೇಳ್ತಾ ಇರೋದೇನು, ರೇಷಿಯೋ ಆಫ್ 2 ಅಂದರೆ ಫಸ್ಟು ಲ್ಯಾಂಬ್ಡಾ ಆಲ್ಫಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಲ್ಯಾಂಬ್ಡಾ ಬಿ ಇ is equal to root of inversely proportional ಅಂದರೆ so mass of BE QBE divided by mass of alpha Q alpha. So when you see that mass ಬಂದು 8 times the alpha ಆಗಿರುತ್ತೆ, 2 times alpha ಅಂದರೆ 4 into charge will 2 times 1 root ಇರುತ್ತೆ. So it is 1:1. ಓಕೆ, ಇದನ್ನ ನಾಲ್ಕು ಇಟ್ಕೊಬೇಕಷ್ಟೆ. Atomic mass 8, alpha particle 4, charge 1, 2. Singly ionized ಅಲ್ಲ, it is 1. So alpha 2 times ಆಗಿರುತ್ತೆ, 2 times of the electron. ಅರ್ಥ ಆಯ್ತಾ? An X-ray tube is operating at 30 kilovolt. Then the minimum wavelength of X-rays coming out is. So you have the formula that lambda is equal to 12400 divided by V. I am strong and ನಾನು ಮಾಡಿದಾಗ. So ಆಗ 12400 divided by 30 second kilo ಅಲ್ವಾ? So ಈಗ 124 divided by 300. So it is 0.413 Armstrong. So option 2 is the correct answer. In a photoelectric experiment with light of wavelength lambda, the fastest electron has speed v. If the existing wavelength is changed to 3 lambda by 4, the speed of the fastest emitted electron will become ಅಂತ ಕೇಳಿದ್ದಾರೆ. So you have the formula kinetic energy is equal to hc by lambda minus 5. So next time ಅವ್ರು ಹೇಳಿರೋದೇನು? So this can be written as half mv square is equal to hc divided by 3 lambda by 4 minus 5. ಈಗ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ you can write this as 4hc by 3 lambda minus 5. So half mv square. So ಈಗ ಜಸ್ಟ್ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡಿದಾಗ let's stand of the photon. So it is going to be increased ಅಲ್ವಾ ರೇಷಿಯೋ ತಗೊಂಡಾಗ. v dash ಟ್ರೈ ಮಾಡಿ ನೋಡೋಣ. ಸೊ ಇದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಾ ರೇಷಿಯೋಸ್. ಇದು ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ 1/2 m v ಡ್ಯಾಶ್ ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಇದನ್ನ v ಡ್ಯಾಶ್ ಸ್ಕ್ವೇರ್. ಇದು ಅದಕ್ಕೆ ಮುಂಚೆ ಏನು ಹಾಫ್ ಎಮ್ ವಿ ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಚ್ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಮೈನಸ್ 5 ಆಗುತ್ತೆ. ಹೌದಾ? ಇವಾಗ ಈ ಈಕ್ವೇಶನು ರೇಷಿಯೋ ತಗೊಳ್ಳಿ. ಅವಾಗ ಹಾಫ್ ಎಮ್ ಕ್ಯಾನ್ಸಲ್. ಸೊ ಉಳ್ಕೊಳ್ಳೋದೇನು ವಿ ಡ್ಯಾಶ್ ಸ್ಕ್ವಯರ್ ಡಿವೈಡೆಡ್ ಬೈ ವಿ ಸ್ಕ್ವಯರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಇದರಲ್ಲಿ 4/3 ತೆಗೆದ್ರೆ ಎಚ್ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಮೈನಸ್ 5 ಮತ್ತೆ ಎಚ್ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಬೈ ಮೈನಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಉಳ್ಕೊಳ್ಳೋದೇನು ಸ್ಕ್ವಯರ್ ಸಾರಿ ಆಗ ಉಳ್ಕೊಳ್ಳೋದೇನು 4/3. ಸೊ ವಿ ಡ್ಯಾಶ್ ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 4/3 ವಿ ಸ್ಕ್ವೇರ್. ರೂಟ್ ತೆಗಿ. ಸೊ ವಿ ಡ್ಯಾಶ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 4/3 ವಿ. ಸೊ ಅಂದ್ರೆ ವಿ ಡ್ಯಾಶ್ ಬಂದು 4/√4/3 ವಿ. √4/3 ವಿ ಟೈಮ್ಸ್ ಗ್ರೇಟರ್ ಆಗುತ್ತೆ. 4/3 ವಿ. 4/3 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 ವಿ ಟೈಮ್ಸ್ ಗ್ರೇಟರ್ ಆ So option D, right? I hope you are clear. Right. Next up. Okay, you have the formula that so you have n is equal to power p divided by e. So first E ಕಂಡುಹಿಡ್ಕೊಳ್ಳಿ. E is equal to ಅಂತ ಸೊ ಕರೆಂಟ್ ಕಂಡುಹಿಡಿಬೇಕಲ್ವಾ? You have the formula I is equal to n into E. ಸೊ ಈಗ ನಾವೇನ್ ಕಂಡುಹಿಡಿಬೇಕು? This is not H. Okay, ಒಂದು ನಿಮಿಷ. They have told you to find I, right? So formula ಏನು? I is equal to n into E. So ಈಗ n is equal to P divided by E. So E is equal to 1240 divided by 400. Produced ಆಗಿದೆಯಾ? Okay, analyze ಮಾಡಿ. So if 0.10%, so 0. ನೀವು ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅನ್ಸುತ್ತೆ. ಓಕೆ, ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. This is nothing but So you'll be getting this as 33.1. So E. But ಇಲ್ಲಿ already if the 10% ಅಂದ್ರೆ into, so 10% ಅಂದ್ರೆ that is nothing but 0.10% ಅಂದ್ರೆ it is nothing but 10 to the power minus 3 number of first multiply ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ n ಕಂಡುಹಿಡಿಬೇಕು. n is equal to power ಎಷ್ಟು 1.5 into milli ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ 10 to the power minus 3 into that much of percentage whole divided by e. ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ ಬಂದಿದೆಷ್ಟು 3.1. ಸೊ 1.5 divided by 3.1 ತಗೊಂಡ್ರೆ you will get it as 0.48 into 10 to the power minus 3. Okay, sorry, minus 3 ಅಂದ್ರೆ minus 6 ಆಗುತ್ತೆ. So it is 0.48 micro n. So ಈಗ I is equal to n into e, right? n ಎಷ್ಟು 0.48 micro divided by, ಯಾಕಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಲ್ಲಿ ಇರಬೇಕು, e into e. So e get cancel. So it is I is equal to 0.48 micro ampere. So option 2 ಬರ್ಕೊಳ್ಳಿ. So I hope you are clear with that. So we'll continue in the next class. Thank you all.